Now the 125mm bore hydraulic cylinders put out a great deal of force, and in order to validate our design, we should perform a simulation on our knuckle kit to see if it can withstand the load. To do that, we'll leverage SolidWorks Simulation. These bolts and washers do not add much to the simulation, so let's remove them for now. This can be easily accomplished with the selection tools to select and suppress them. We may also want to add the rod eye to this assembly to better define the load transfer, and with a quick search we can find this part and add it to the assembly. Let's center the rod eye up with a width mate and then locate it in what will probably be the most extreme loading situation. Notice that when I add a mate between these two faces, SolidWorks warns me that the default coincident mate will not work, so we'll choose an angle mate and place it at 35 degrees. Looks perfect. Now we'll do some simulation. In this case, we'll choose to do a static simulation study. Next, we need to hold our assembly by adding some fixtures. We'll start with fixing the two end caps so that they have no movement. Then we'll add a sliding fixture to the wear plates, as they are free to rotate on the support bracket. Finally, we'll apply a force to the rod eye. This will be 180,000 newtons to represent the load from the hydraulic cylinders. That's it, and we're ready to run the simulation. At this point, SolidWorks automatically meshes the parts, establishes the contact between the parts, and runs the analysis. With the fastest solvers in the industry, we are presented with the results in no time at all. The colors on the part correspond to the stress values listed on the right, but since we're analyzing an assembly of parts with different materials with different yield strengths, we'll be better served with a factor of safety plot. This plot identifies the ratio of the stress to the yield strength of each part. For our knuckle, we want to have a minimum factor of safety of 2, so we can change our chart and disregard any values above, say, 4. We can see that there are areas in our knuckle that do not meet our requirement of 2 for the factor of safety, so we're going to need to make some changes. With SolidWorks, there's no need to start over. Let's just edit the part and make some changes that will strengthen the area of concern. Let's change the thickness from 25 to 30 millimeters, and we should probably increase the size of the fillet. But remember, when we created the fillet, it included a bunch of edges that should stay the same. Well, this isn't a problem. With the Fillet Expert, it's easy to change individual fillets without destroying others. We'll choose these two fillets and resize them to 30 millimeters. SolidWorks separates them from the others, preserving our design intent. As we go back to the simulation, all of our loads and fixtures are intact, and all we have to do is hit run, and SolidWorks will rerun the simulation with the new geometry. As we look at the factor of safety plot, we can see that we now meet our minimum factor of safety requirement of 2. Problem solved, and we can rest assured that our part won't fail in service. Let's bring back the bolts and washers and remove the rod eye, since we already have those in the boom assembly.